మనము రివర్స్ లో పోతే అదే అన్నారు.
Started.
I welcome you all for the last session of today's FDP. Now I request Mr. Pasha to continue.
Thank you, MBG sir. Yes, dear participants, welcome back to this session. In the last session, we discussed solution of non-linear boundary value problem, second order non-linear boundary value problem using shooting technique. So where I had to guess only one initial value. Now let me give details related to fourth order and the two unknowns, and then quickly solution procedure for coupled differential equation properly. Consider fourth order differential equation. Numerical solution of fourth order non-linear boundary value problem using shooting method. Using shooting method. So fourth order equation will be like this: f of x, y, y dash, y triple dash with some boundary conditions. Okay, assume that conditions are like this. Suppose y at a is given some number, y of a is ya, y of b at the end point is yb. Y of a is ya, it is useful for my initial value problem. This is not useful, y of b, so one unknown. Y double dash of a is given. Y double dash of a is given some number y to a. This is useful because it is at a. And fourth order, so one more condition is required. Y third order derivative of b is given. Y3 of b is given. Y3b, not b of b, some number y3b, 1, 2, 3, whatever it be, some number. I'm calling it as y3b. So out of these four conditions, I have an issue with conditions specified at b. So there are two unknowns now. I have to guess these two values. What? Y dash and y third derivative at a I have to guess. So let me write it properly once again. Analyze. Y of a given y a, y of b given some y b, y double dash of a given y to a, y third derivative of b given, so it is y3b. No problem with this, no problem with this. I don't want these two to get initial value problem. So the ideal conditions must be like this. Y dash is not given, so y dash of a, I have to assume it as s. Y double dash of a, no problem, y to a. Y triple dash of b, so y triple dash at a is equals to t. I have to improve these two values. So there are three conditions, two conditions I have to check. Condition number 1, y the solution of the initial value problem at B, because this one, no, y of B is the condition which I am excluding. So the condition which I have to check is for y at B associated with the initial value problem. This minus the actual value should be close to 0 or equal to 0. This is the first condition that I have to check. I'll call this as phi1, which is dependent on S and T, the initial slopes that you take, initial values for y dash and y triple dash. One. And the second condition is on third derivative. So y third derivative of the solution of the initial value problem at B must match with the boundary condition y to B. So its difference should be close to 0. This is phi 2. I have two conditions to be satisfied here. The previous case, one condition, here two conditions. So depending on the number of equations, order of the equation, number of unknowns, these conditions increases. Okay, so I'll start with an arbitrary approximation, say SK, TK. Assume that SK plus delta S, I have to fine tune it. That delta S is the missing thing. If I add delta S to SK and some delta T to TK, this becomes 0. Same thing happens for the second condition. This is an initial guess. For this, it may not satisfy. I have to fine tune it and determine delta S and delta T such that these two conditions are satisfied. Now you have to expand these two using Taylor series, Taylor series expansion of function of two variables. When you expand the first equation, you get it is function of SK comma TK plus delta S into derivative of phi1 with respect to S, dou phi1 by dou S. Of course, it is SK comma TK plus delta T into dou phi2 by dou S SK comma TK plus dot higher order terms is equals to 0. This is the first equation. So from this equation, if we ignore the higher order terms, we get, if we ignore higher order terms, we get what? This is unknown. Delta S is unknown, delta T is unknown, this is known quantity. Dou phi1 by dou S. Known means we can determine. By solving initial value problem, I can determine. Dou phi1 by dou S into delta S. Of course, it is at S. At SK comma TK into delta S plus dou phi1 by dou T. This is also at SK comma TK into unknown delta T is equals to, shift this to right hand side, you will get minus phi1 of SK comma TK. So I have one equation. Similarly, from phi2, I'll get a similar equation. What is that? Dou phi2 of SK comma TK divided by delta S, dou phi2 by dou S into delta S, dou phi2 into delta T is equals to minus phi2 SK comma TK. So it's a matrix like this, Ax is equals to B. I have to solve this matrix where A is the coefficient matrix, dou phi1 by dou S, dou phi1 by dou T, dou phi2 by dou S, dou phi 2 by dou t. This is like this. A. B is the right hand side part, minus phi 1, minus phi 2. These things should be expressed in terms of y1, y2, y3. Solve that, and Ax equal to b, solution either A equals b, or you can use using the built-in command x slash b, you can use and solve this. Not a big deal. So determining these things is important. Then you will get delta s and delta t. Then you can improve the values of sk. So sk plus 1 iteration is sk plus 1 is equals to sk plus delta s, tk plus 1 is equals to tk plus delta s. You can improve this. Okay. I'll directly take a couple differential equation of this right. F triple dash is equals to 24x plus 8 theta minus 2f dash minus 8 theta double dash is equals to 6x plus f double dash by 4 plus 2f dash minus theta dash minus 8 theta plus 8. So I have to solve this for f1 theta. You get such equations when you solve problems related to fluid flow, temperature equation here and the velocity equation there. So degree 5 here, third degree here, second degree here, 5 conditions required. Suppose conditions are like this: f of 0 is equals to 3, f dash of 0 is equals to 0, f double dash of 1 is equals to 12, theta of 0 is equal to 1, theta dash of 1 is equals to 3. Out of these three, I have no problem with the first equation, second equation, third one I have to guess because it is at 1. So I'll call f double dash of 0 as s. Theta of 0, no problem, but problem is with the theta dash of 1, I want theta dash of 0. Okay. Solution procedure now. Third derivative is here, so I have to write f till third derivative, theta till second derivative. Okay. Same procedure, I'll call f as y1. F is equals to y1. F dash is derivative of y1 with respect to x. I'll call it as y2. Equation is still f, third derivative is given. So you have to write f double dash is dy2 by dx. Call it as y3. F triple dash, I have to stop here. So I'm not calling it as y4. That is important step. I'm not calling it as y4. F triple dash is dy3 by dx. dy3 by dx is equals to this equation, this entire thing. Timing, let me call it as F1, right hand side part. And I'll call this as F2. Okay, this is equals to F1. Next. After F, till F third derivative, because third derivative is given, stop, continue with theta. You have to continue. I have defined till y3, so theta has to be y4. Now theta is given till double derivative. Theta dash is the derivative of y4 with respect to x, call it as y5. Theta double dash, you have to stop, so you are not calling it as y6, you have to stop at y5 only. You know the equation d5 by dx is equals to given, I have denoted it as f2, let me write it as f2 here. Okay, done. Now, F1, let me write F1, because F1, what I have assumed is from this equation, but the roles have changed. Everything should be in terms of y1, y2, y3, y4. Roles have changed, so x will remain as it is theta. Theta is y4, I guess. F dash value, F dash is y2, I guess. So F1, similarly F2, you have to express F1, F2 in terms of yi's. Let me write F1. F1 is equals to 24x plus 24x plus 8 theta minus 2f dash minus 8. This implies, okay, this is, you know, this stands for third derivative. Fine, let me do that. So f1 is equals to 24x. I'm not changing this. Theta is y4. F dash is y2 minus 8. This is f1. Next, f2. F2 is equals to 6x plus f double dash by 4 f double dash by 4 plus 2f dash minus theta dash minus 8 theta plus 8. Simplify this now. F2 becomes 6x f double dash y3 by 4, f dash is y2, theta dash is y5, theta is y4, and here becomes 8. I have expressed f1 and f2 in terms of yi's. Now the conditions. Conditions are like this. F of 0 is equals to 3. F dash of 0 is equals to 0. F double dash of 1 is equals to 12. Theta of 0 is equals to 1. Theta dash of 0 is equals to, now theta dash of 1 is equals to 3. These are the one conditions. I don't want these two. They are given at 1. Okay, so I have to assume it as S and T. Before that, F. F is associated with Y1, F dash is Y2, F double dash is Y3, theta is Y4, theta dash is Y5. Write equation in terms of these things. So Y1 of 0. Y1 of 0 is equal to 3. Y2 of 0 is equal to 0. Y3 at 0 is equals to S. Next, Y4 of 0 is equals to 1. Y5 of 0 is equals to T. These are the two conditions now. But as I've illustrated in the previous case, when there was one unknown, you had another set of initial value problems, Q. Here there are two unknowns. Two more set of initial value problems will come along with S. One associated with S, another associated with T. So for the one equation which is associated with S, all other terms will become 0. That is, if I am writing U, when I am writing U, for U, which is associated with S, all conditions become 0 except the condition, because there is S involved here. If I consider one more initial value problem corresponding to T, conditions, in condition everything becomes 0 because we are differentiating with respect to T and derivative of T is 1. So these two sets are with these boundary conditions. So let me define the two set of differential equations. Now the condition, what happens to the conditions? Phi1 of ST is equals to okay. So I want condition associated with Y3. The Y3 value, the initial value associated with Y3 at 1 should match with this number. Similarly, Y5 value at 1 should match with this number. Let me write the conditions. Phi1 of S comma T, so it is Y3, related to Y3, the initial value problem. Solution at B should match with the given condition Y3 of B, where this Y3 of B is F double dash of 1, that is equals to 12. This part is 12. Condition number 2. Condition number 2, phi 2. Phi 2 of S comma T is equals to phi 2. So Y5. Y5 initial value problem. At that I substitute S equals to X equals to B. This should match with the condition Y5B. Y5B is nothing but theta dash of 1, which is equals to 3. Okay. Next. I have to define U. U is equals to dou by dou s of y of x comma s comma t. If you remember the first problem, okay. There was a dependency of this equation on S. As there is a dependency on S, I have written equations like this in terms of S. I have determined the derivative of y double dash with respect to S. So it was like this using chain rule. In this case, number of variables increases. There it was only f function of x, y, and y dash, but here terms are more. And I denoted u to define the first set of initial value problems. Y, which was a function of x and s, the derivative of y with respect to s was taken as u in the first problem. Here, y depends on x, s, and t. So, dou by dou s is taken as u, dou by dou t is taken as v. So, from that you get two more set of differential equations, and then u double dash. From the counterpart of, I have told you, the counterpart of y double dash is u double dash. Similarly, v double dash you have to write the counterpart. How? It is written like this: dou f by dou y, dou f by dou y dash, and so on. Means dou f by dou y1, dou f by dou y2, and so on. It is defined like this. In a similar manner, we have to write when y depends on x, s, and t. Okay. So same thing. U is dou by dou s of y, x, s, t. So U1, I'll denote U1 as U only, which is dou by dou s of y of x comma s comma t. Dou by dou s of y of x comma s comma t is U1. Now I define U dash. U dash as U2. U dash is du. I have told you earlier that the dashes primes denotes differentiation with respect to x. So u dash is du by dx here. Du by dx, nothing but du1 by dx. du1 by dx. d by dx of u1. U1 is dou by dou s of y of x comma s comma t. Now interchange. This is equals to dou by dou s outside d by dx of y of x comma s comma t. That is equals to dou by dou s of dou by dou x of d by dx. y1, y is y1. Y, I am denoting y as y1. dy1 by dx is y2. Okay, so u dash, that is u2 is dou by dou s of y2. This term is y2. Therefore, u2 is equals to dou by dou s of y2. Which is nothing but u dash. Similarly, I can find u double dash. U double dash is equals to dou by dou s of y3. Increase the suffix. That's it. U dash is dou by dou s. U double dash is dou y3 by dou s, and so on. D, the another set is related to T. Similarly, we have V as dou y1 by dou t, V dash as dou y2 by dou t, V double dash is equals to dou y3 by dou t, and so on. Fine, we are ready to go to form the differential equations now. Now, the main problem here is this one. I was trying to solve this differential equation. Expressed equation like this, y1 to y5. So there will be counterparts, u1 to u5, v1 to v5. Means total 15 first order differential equations will be there now. 15 equations. I have written f1 and f2 in terms of yi's like this. Conditions, I have assumed these two, s and t. So corresponding conditions in their counterpart are like this. y3 and y5 are unknowns. So conditions has to be written in terms of y3 and y5. I have used the Taylor series. I have to use Taylor series for sk and tk. I have to improve the values of sk and tk. To solve that system, Ax equals to B. This is what I have expressed it related to fourth order differential equation. So you had a matrix like this A. For first condition phi1, the matrix of unknowns is like this. Dou phi1 by dou s, dou phi1 by dou t, dou phi1, dou phi2 by dou s, dou phi2 by dou t. Your main aim is to express this in terms of yi's. That is the task. Okay. Phi1 is y3 of bst b comma s comma t minus y3 b. Differentiate this with respect to s. Dou phi1 by dou s. It is a function of s. This part is constant, so it is dou by dou s of y3. dou by dou s of y3, and you know that dou by dou s of y3 is just u double dash. I have completed u double dash at b. This is at b of s comma t. Dou phi 1 by dou t. Dou phi 1 by dou t is dou by dou t of y3 of b comma s comma t minus 0 here. Dou by dou t related to t, it is v. Simple rule. I have derived here. Related to s, it is u. Related to t, it is v. Y3 means one derivative come. Here also y2, one derivative less. Y3, y2, v double dash. Same logic here. Dou by dou t means v. Y3 is there, so it has to be y double derivative at the end point. So this is over, this is over. When I know u double dash, I can write it in terms of y1s. I can continue as I have continued in the previous case. Next, dou phi 2. This part. What is phi 2? Phi 2 is y5 of v comma s comma t. Solution of the initial value problem at x equal to b. Related to that y5 part minus y5t, the boundary condition. So here dou phi 2 by dou s is nothing but dou y5 by dou s at b. With respect to s, I am differentiating, so it is related to u fourth derivative. Next, if I differentiate phi 2 with respect to t, I'll get dou by dou t of y5 b comma s comma t. That part is 0, constant. So derivative with respect to t associated with b, number is 5, so power is 4, fourth order. So I can write capital A now, A matrix. Therefore, capital A is equals to u double dash of b, b double dash of b, u fourth derivative, okay, correct. U fourth derivative of b, b fourth derivative of b. This has to be changed in terms of y1, y2. So when I give the order, y1 to y5 for y, and then the next 5 for u, next 5 for b. From that you have to extract here in terms of y. This is the coefficient matrix. So let us write the initial value problems now. So IDP 1 associated with y. I have already written f as y1. F dash is derivative of y1 with respect to x, which is y2. F double dash is derivative of y2 with respect to x, which is y3. F double dash is given, so f double dash, I will not call it as y4, it is dy3 by dx only, which is equals to f1. F1 I have already converted it, it is 24x 8y4 minus 2y2 minus 8. Next, Next, related to theta. Continue the numbering. Theta is equals to y4. Next, theta dash is equals to dy4 with respect to x. Call it as y5. Theta, second order was given, so theta double dash you have to stop. Means I'm not continuing the numbering here. It is just derivative of y5 with respect to x. Theta double dash is f2. F2, we have simplified it. It is 6x plus y3 y4 plus 2y2 minus 8y4 plus 4. So one set is over. Second set related to you have to write. I have told you, remember, u is the counterpart of this. When I'm writing u1, u2 here, u1, u2, u3. At this point of stage, you have to write the corresponding thing. What was that? Summation dou f1 by that variable dou y into something ui was there. Related to problem 1, the same concept should come here. You have to differentiate this with respect to y, y1, y2, y3 and so on, and write the counterpart for f triple dash. Same thing comes at this point. All are interlinked. We are just extending the same concept. So let me write initial value problem 2. This is related to u. IVP 2. I have to start with u. U is equals to y6. I'm continuing the number now. So it is u1. U is u1, nothing but y6. U dash. U dash is y7, nothing but du1 by dx. Or when I write program, let me write that in terms of okay, let it be. Simultaneously, I will give the code for program also. Continue number y6, which is u1. U dash stands for derivative of y6 with respect to x. That is equals to y7. Next, continuation. U double dash derivative of y7 with respect to x. dy7 with respect to x. Call it as y8. In terms of u, if you want to write, it is u1, u2, u3. When it comes to u third derivative, the counterpart of f third derivative you have to write. U third derivative is equals to dy dx of y8, and I'm not calling this as y9 because f is still third derivative, so I have to stop here. Dy dx of y8, which is nothing but dy dx of u3. The counterpart is related to f1 summation k is equals to 1 to 5, y1 to y5. Dou f1 by dou yk into uk. Means this is dou f1 by dou y1 into u1 plus dou f2 by dou y2 into u2, dou f3 by dou y3 into u3, and so on. Dou f3 by dou y4 into u4. We can convert u in terms of y later. Plus dou f3 by dou y4 into u5. 5 here. Okay, everything is F1 only here. This is F1. Okay. What is F1? F1 is 24x plus 8y4 minus 2y2 minus 8 is F1. So derivative of F1 with respect to y1, there is no y1 term, this becomes 0. F1 with respect to y2 minus 2. F1 with respect to y3, there is no y3. F1 with respect to y4, one term it is 8. F1 with respect to y5, there is no y5 term, 0. Definitely, f depends on x also. I have not included that derivative because x and s are independent variables, x, s, t. So that variation with respect to x I have not considered. The other variations, chain rule, it is, I have considered. So I have an expression for u triple dash now, which is minus 2 into u2 plus 8 into u4. Therefore, u triple dash is equals to minus 2 into u2 plus 8 into u4. I can convert all these things in terms of y. There's an expression for u, third derivative in terms of y, u2 and u4 in terms of y. So we can write the program. Next. After this, till u3 we define, u4 is associated with theta. IVP2, IVP1, same continuation. Theta y4 associated with u, it is u4. Theta dash here, continue u5, and then counterpart of this summation, the chain rule you have to use for f2. So related to theta now, you have du4. The variable u4 is associated with theta, so du4 by dx is equals to u5. Next derivative is f2. du5 by dx is equals to counterpart of f2. In this case, it is summation dou f2 by dou yk into uk. Same thing, where f2 is x f2 is equals to 6x plus y3 by 4 plus 2y2 minus y5 minus 8y4 plus 4. This is f2. Therefore, du5 by dx is equals to summation dou f2 by dou yk into ik or uk. That is equals to summation F2 is here with respect to y1. I'm not differentiating with respect to x as it is independent. Dou F2 by dou y1 into u1 plus dou F2 by dou y2 into u2 and so on. We differentiated dou Fy by dou y5 into u5. So you have another set of initial value problem related to u. Next, same way you have to write differential equation for v. Set of differential equations for v. Okay, so I'll assume that you can complete these things. So I'll write the coding part. Okay, I'll just write. I think may not be able to demonstrate that. I'll share the program associated with this. I'll just write the coding part. How in the running format from y1 to y15 we write. From those, what I have derived 5 equations for u, 5 equations for v. In a similar manner, you have to derive, and then you have to write all those things in one related to variable y. So I'll illustrate that part. Working procedure. Working procedure. First set for IDP1, you know these things. I'll start with f is equals to y1, then derivative of y1 with respect to x is y2, derivative of y2 with respect to x is y3. So this is f dash, f double dash. For f3, f double dash, we have an equation. We had an equation. So that part you have to write. Third derivative, dy3 by dx is equals to that equation, capital F1. Next, continue. Theta. After f, for theta terms, you have to write theta is equals to y4. And then dy4 by dx is equals to y5. Theta was in the second order, right? So I have to stop at this stage. d5 by dx. I should not call it as y6 because the equation is here. This part is f2. d5 by dx was f2, f1 and f2. Over 5 equations. Now continue with IVP2. Related to IVP2, we have to consider y5 is over. Now variable u, call it as y6. Same counterpart you have to write. U is counterpart of f here. Next, u dash. U dash is d by 6 by d7. This is f dash now. F dash, f double dash, f triple dash. This is theta dash, theta double dash. So same thing. U dash is d y6 by d7. I will call it as y7. U double dash is equals to d y7 by dx. I'll call it as y8. U third derivative, you have to be careful here. It's counterpart of F third derivative, but it is not F1. That rule, it is summation. What is that? Dou F1 by dou Yk into Uk. That part, in terms of Y, you have to convert. U, when you write, this is U1, U2, U3. U2 is nothing but Y7. U3 is nothing but Y8. These U terms should be in this order when you write it converted. This is U1, this is U2, this is U3, and so on. U2 is Y7. Replace U2 by Y7 there. U3 is Y8. Wherever U3 comes, replace that by Y8, and so on. So you have to express U third derivative in terms of Y only. We have U third derivative in terms of U, converted in terms of Y based on the order what we have obtained here. Next, U3 over theta. The same thing associated with U4 now. U third derivative over. So till what? Till what I have done? 8. So Y9 is Y9 is that counterpart of theta. Y9 is counterpart of theta, that is U4. Next, derivative of Y9 with respect to X, I will call it as Y10. This is counterpart of theta dash. Counterpart of theta double dash is dy10 by dx. Remember, I'm not calling it as y1 over theta double dash. So dy10 by dx is equals to, what is it? F2 part. F2, now instead of F2, you have to write this. Summation dou F2 by dou Y into Yk. K is equals to 1 to 5 into Uk. 5 equations. Now same matter with V you have to write. V till 10 over V is Y11. Next, which is nothing but V1. V2 is derivative of Y11 with respect to X. Call it as Y12. Next, V double dash, that is V3. D, this is corresponding to F, this is corresponding, okay, F dash, this is corresponding to F double dash. D Y12 by dx, call it as Y13. Now, the third equation associated with F third derivative V4 is derivative of Y13 with respect to X. I'm not calling it as Y14. It is summation of counterpart of that F1. So F1 by, what is that? In terms of T, you have to write. Dou F2 by dou Yk into Vk. Running numbers for Vk here, K is equals to 1 to 5. Next, Y14 is counterpart of theta associated with theta. Here it is, I think, okay, fine. y13 till y13, next y14 for theta dash dy14 divided by dx, and finally the last equation, call it as y15, final equation theta double dash dy15 by dx corresponding to f2. It is summation dou f2 by dou yk into vk, where k varying from 1 to 5. Program remains same. Condition in the case where S was single, Newton-Raphson formula sk plus 1 is equal to sk minus that f of s by f dash of s part. Here I have told you, you will get a system like this, Ax equals to b, and in this system you have to convert this coefficient matrix A in terms of yi's. If you remember, we have written it as, we got A we got A like this, dou phi 1 by dou s, and also after simplification, we got A like this, u double dash of b, v double dash of b. For u double dash in that program, it is in terms of y. If I'm not wrong, u was y6, maybe it is y7, I guess. Y7, and it is b required, y7 of n, the last number, where n is length of y. Same concept here, v double dash, maybe it is 13, y13 of n, v fourth derivative, something, some number, maybe y9 of n, and here y14 now. Maybe it is 12 here, cross check, something like this. In terms of y, you have to write. All these things can be obtained when you solve those initial value problems. Using the 2D 45 solver, similar procedure, find it and solve that system. Ax is equals to b using the formula x equals to a slash b. What is that? This one or backslash what it may be. You have a command to solve the system of equation directly. Use that. Iterate. You check the condition. We checked one condition there. Here you check two conditions. Absolute value of condition number 1 and condition number 2, if that is less than tolerance, then proceed, and so on. The same thing extended. Anyhow, the program for this will be shared. Interested participants will, you attempt it, and in case of doubts, you can always contact the coordinators. With this, I'll end the session. If there are any doubts, you can ask. I'm ready to answer. MVG sir, over to you.
Thank you, Pasha.
Asha,
Yes, ma'am.
thank you. Thank you so much.
Thanks for the opportunity, ma'am.
We thank you, Pasha, for your complete effort that you have put to present 2 sessions.
Thank you, sir.
Within a short notice and a short period of time as well. Wholeheartedly from our department, we thank you. And we thank all the participants who participated for this session. And tomorrow we have a last session, and thereby we conclude the FDP as well. I request and I hope you all participate in tomorrow's event as well, tomorrow's session as well, the way you have participated in the entire FDP. So we request you to tomorrow also participate online, offline, and thereby we conclude the FDP. Thank you one and all. Tomorrow we'll meet.
Bye, Pasha.